Hi folks, welcome back to Physics with Captain Rod. Making this video here to help you out with problems 11 and 23 in Chapter 4. Both of them mention a rocket, so I decided to put them in one video here. So, alright, starting with number 11. So 11 says a rocket sled accelerates at 49 meters per second squared. Its passenger has a mass of 75 kilograms. Calculate the component of the force the seat exerts against the body. So here's my kind of picture here. And here's young Timmy here apparently is riding our rocket. So when you're working these problems, the first thing you should be doing is draw a good picture that describes the problem. And I've kind of done that here. I've got a picture. I've got my rocket and the rider. I've got the relevant data written down somewhere. We may want to actually do some more in our picture. The rocket's accelerating, which means the velocity would increase. And remember how we kind of show that with a motion diagram. So this dot here is going to kind of represent the snapshots in time, right? So the rocket's velocity is going to increase as time goes on because this rocket's accelerating to the right. Now, this is a Newton's second law type of problem. Remember, Newton's second law is net force is equal to mass times acceleration, and Newton's second law is a vector law. These are vectors. And in order to apply it, you want to draw what are called free body diagrams. Now, it's tempting here to maybe draw a free body of the rocket. I'm going to go ahead and do that here, even though it's not what's asked for in the problem. But if we drew a free body of the rocket, we'd have the gravitational force down equal to mg. I'm going to put a big M there, meaning the mass of the entire system. The ground is in contact with the rocket. That's going to give a supporting force on the rocket. That force is upward. That's going to be an example of what we would typically call a normal force. The engine for the rocket is going to produce a force called thrust. Right? That's going to push this way on the rocket. I'm just going to put a force there. And that'd pretty well be it. Now, some things I like to point out. Where you put these force vectors does not really matter, like this normal. You could put it anywhere along this line. Forces have what's called a line of action. Whether you put your force vector this, kind of like it's pulling, so to speak, or maybe I could have drawn it here like it's pushing, that doesn't matter. Both are perfectly correct. This force vector can go anywhere along this line of action. Same thing with this mg, can go anywhere along the line. This force can go anywhere this way. So that's, this is what a free body of the system might look like. Now, in my free body here, I'm ignoring air drag, and it doesn't say anything about air drag. So sometimes it's reasonable to do that, sometimes not. Now, again, I wanted to kind of give a free body of the rocket, although the question really is not about the rocket. The question asks for the force exerted by the seat on the person. So what you're going to want to do now is draw a free body of the person. I'm going to start with kind of a picture here, and I don't want to do the free body because it's your homework, but you'd start with kind of a snapshot of what this person maybe looks like sitting in this rocket. Maybe something like this. Not the best picture, I realize, but here's young Timmy. And then start putting force vectors in. Young Timmy would have a certain weight, so you put a vector in for that. It's going to point down. When you calculate it, Timmy's mass is given in the problem, 75 kilograms. The seat. The seat has to exert some sort of upward force here. Otherwise, Timmy would be accelerating down, right? So you're going to have a vertical force due to the seat, no doubt. The seat also is going to be applying a force on Timmy to the right as well. So you want to put that force vector in the free body. So put two different forces in for the seat. One's going to be to the right, one's going to be up. Right? The vertical force is basically keeping Timmy from falling. And then the horizontal force is what's going to be accelerating Timmy, because if the rocket's accelerating at 49 meters per second, and Timmy's in the rocket, he also is accelerating at 49 meters per second. After you get your free body done, you can write two equations. Sum of all forces in the y direction is equal to 0. Now the reason, Timmy's not accelerating up. The acceleration direction is this way. It does not have a y component, so the net force in the y direction is 0. Second equation you can write is sum of all forces in the x direction is equal to ma, and I would do right positive. Right? Timmy is accelerating in the x direction, so that should be enough to get you through that problem. It's just about done there. right, let's talk about number 23 there, where it says, let's see, a 5 times 10 to the 5th kilogram rocket. So you should be writing that down. Right? 5 times 10 to the 5th kilograms. And again, that's the mass of the entire system. It's accelerating up, but a value is not given. What we are given is that the engine produces a force of 1.25 times 10 to the 7th newtons of thrust. So that's a force vector we can put on the rocket, and that force vector would be up. Right, so that force is given. Now, other important forces. The rocket, the entire system here has a weight, mg. That force vector will go down. I'm not going to draw it as it's your homework. Notice I got Timmy in the rocket here. He's riding it upward. Other possible forces. Air drag may be an important force here, so we might look for that. It says there's an air resistance of 4.5 times 10 to the 6 newtons. Now, air resistance always opposes motion, so you got to decide what direction to put that force. So draw your free body of the rocket this time. It's going to have the force produced by the engine, it's going to have an mg, and it's going to have an air drag. So your free body should have 3 forces. Then write out the following equations. Sum of all forces equals ma. I would go ahead and do up positive. Your left-hand side will have 3 forces, and then equals mass times acceleration. That should be enough to get that problem done. So, all right, hope this video helps. Have a great day.